Have you ever touched a steel thali in a cool AC room and felt it instantly feel very cold? That happens because heat is leaving your hand very quickly. Your hand is warmer than metal, so heat flows from your hand into the steel. Metals allow heat to move through them very fast, almost like a smooth pathway of energy. Even long ago, people understood how heat behaves in practice. In traditional Indian knowledge systems like Rasa Shastra, metal workers used clay containers called mushas to handle hot metals safely. The clay slowed down the heat transfer and protected the surroundings, while the metals inside could be heated efficiently. So, what exactly is this movement of heat and how does it travel? You can actually observe this yourself. If you take a metal spoon and a wooden spoon and expose them to the heat in the same way, you'll notice something interesting. One responds much faster than the other. Let's understand why. Let's zoom in. Everything around us is made of tiny particles called atoms. In metals, these atoms are packed very closely together. While one part of the metal gets hot, its atoms start vibrating faster. Now, these vibrations pass energy to the nearby atoms one after the another, like a chain reaction moving through the material. This transfer of heat through direct contact is called as conduction. And there's a simple rule: heat always flows from a hotter region to a colder region. So, when the heat is applied to the spoons, it travels quickly through the metal but much more slowly through the wood. That's why the change happens faster in a metal spoon. And that's exactly why metal feels colder to touch, because it pulls heat away from your hand faster than materials like wood or plastic. The mathematical understanding of this entire process was developed by Joseph Fourier in the 19th century. Today, engineers use these ideas in real systems. In smartphones and computers, metal components carry heat away from the processors. In electric vehicles, heat from the batteries is carefully managed to prevent overheating. And in spacecraft, materials are designed to control how heat moves in extreme conditions. And if this excites you, you could become a thermal engineer, someone who designs systems to keep machines safe and efficient. You could help build better electric vehicles, more powerful computers, and even technologies that work in space. So, next time you touch a metal spoon or a plate and feel that sudden chill, remember that heat is moving from your hand into the metal. I'm Dr. Kavita from Urjeevi Spark. If you enjoy understanding things like these and want to do hands on learning, you're always welcome to join us. Stay curious. I'll see you in the lab.